Many of the topics that we are about to cover in this book are very large and cannot be demonstrated in class, and yet are very interesting. There are two types of controls: motion, as in machine tools, robotic arms, and moving vehicles, and process control, where you're trying to produce a product but that you have to control certain parameters, such as the temperature, the chemicals, humidity, etc. There are two types of process control. The first is the batch, where you might be making a product such as cookies, but the very next day you could be making something else such as bread, where the equipment remains the same, but the product is changed and the ingredients also change. In a continuous process, there is only one product that never changes, and the production must be maintained continuously. And then the trick is to maintain the production and control the parameters without stopping the procedures. And this is something that's quite challenging. In this example, we have the manufacture of paper, but a better example would be the petroleum industry, as in a refinery or water treatment plants. Imagine that in centuries past, you're trying to produce a product, say wine or something else, in a big old storage tank. In that case, you would have some poor person, maybe a child, working that manual valve to maintain the desired level. This is an example of open loop, where you send a signal to the control valve, but there is no signal coming back. In a closed loop system, you have a sensor, in this case a float, which would try to maintain a desired level, which is called a set point. When you reach the set point, a signal would be fed back to the valve and close the valve. When you think about it, what we have here is a glorified toilet tank. But in fact, this is an example of a closed loop system with feedback. The previous examples were pictorial, but in reality, closed loop diagrams were made for further analysis. In this case, a set point must be maintained. A measurement is taken and sent to a controller, which is usually an electronic device, such as a microprocessor. A signal then goes to an actuator, which could be a valve. The whole thing is considered a manufacturing process, and it continues with measurements being taken until the error is completely eliminated. Here's an example of a system where we're trying to maintain the temperature of water. In this case, a measurement is taken and a signal is sent back to the controller. Here then is a closed loop with feedback. In feed-forward control, an attempt is made to anticipate an error. In this case, a measurement is taken of the water before it comes into the tank. The idea is to begin the heating procedure sooner. Most of the time, feed forward and feed backwards are used together, with the idea of speeding up a procedure that could take many hours or even days. In this case, maybe the tank is so huge that we need to speed up the procedure to save many, many hours of work.